chapter 11 is actually where we're going next. Obviously, we just did chapter 9, so you would think chapter 10 next, but just to give you an FYI, we are changing the order mainly because of EOC, okay? Yeah. We want to get through chapters 11 and 12 for sure because that's what we find more is on the EOC. So it's kind of our way of just making sure we can get through the content before that test, okay? Now, chapter 11 is one of those chapters that has a variety of things. You're going to see area of polygons, maybe even circles. You're going to see talking about angles in this section. Perimeter even is involved. Similarity. There's a lot of different things.
Yeah. Focus is on area, but all this stuff is going to lead up to the area. So
all right. So section 1 is going to be kind of more talking about just the angles in a polygon. All right, so this table here, we're going to have you guys fill this in primarily by yourself, but we're going to get you started, okay? So the first column, you guys can nail this pretty easily, all right? So how many sides does a triangle have?
3 sides in a triangle.
And a quadrilateral?
4 sides.
Pentagon?
5 sides.
Hexagon?
6 sides.
And decagon?
10 sides.
Now, what about an n-gon?
An n-gon was a way that we said for a random number of sides that's not something that we have a specific name for. So we'd say there's just n sides.
N amount of sides.
So if I said a 17-gon, it'd be 17 sides.
Right. Okay, now, what our goal is, and I want to just kind of give you this preview in a sense, our goal is this last column, right? We're going to be focusing on what's the sum of interior angles of any type of polygon. Okay. So our biggest goal is this last spot right here. For any n-gon, what's the sum of the interior angles? That's what we're going to kind of go with. All right.
Okay.
So this table allows us to kind of look for maybe a pattern with some things. So keep that in mind. So we're going to start you off. Now, this column here says the number of triangles. So what we mean by that is when you have a polygon and you create some diagonals. Okay. We want to figure out what's the fewest amount of triangles that are formed. Well, in a triangle, if I draw a triangle, is there any diagonals?
There's no diagonals.
So then that means a triangle is
just
one
triangle.
One triangle. Okay.
And we already know the sum of those interior angles is going to be 180 degrees.
So this is going to be our goal. Okay. We're going to generalize it because we won't want to create a table every single time we do this. Okay?
Right.
You're going to see what we're talking about. Okay, let's go to quadrilateral. Now, quadrilateral has 4 sides. We don't know what kind of quadrilateral. It doesn't matter. So let's create a diagonal. Let's say this one right here. Does that create some triangles?
Yes, it makes 2 triangles.
2 triangles. So there are 2 triangles in any quadrilateral.
Right. And I could draw in the other diagonal, but then I'm forming more triangles. We want the fewest number of triangles.
I love that you said that. You're reading my mind. All right, so we already know quadrilaterals, the sum of the interior angles adds up to
360.
Now, another way we knew that, we explored this back in chapter 6, is in one triangle, we know the sum is
180.
And if there are 2 of them, so if I do like 2 times 180, so the number of triangles times one triangle sum, that's where I'm getting the 360. Even in a triangle up here, there's 1 triangle times the sum is getting you that 180. So keep that in mind, okay? So what you're going to do, basically, from here on out, is you want to draw, I would draw the sketch, okay? So like a pentagon, 5 sides, okay? And then you want to draw the fewest amount of triangles. So if I draw in...
There's one
diagonal. Now, this is not a triangle, so I have to draw in at least another one. Do I have triangles?
Now I have all triangles.
Okay, so that means there are
3 triangles.
3 triangles. Okay, so then how much does the interior angles add up to?
Well, if there's 3 triangles, I'm guessing 3 times 180.
Yeah, and each of them is 180, so 3 times 180 is what, 540? So we want you to figure out in the end, this right down here, but thinking about with a hexagon and decagon, okay? If there's a pattern, look for it. So do that and then come back and check with us. Okay, so instead of drawing, I'm not going to draw all of these. So a hexagon, how many triangles did we end up with?
There were 4 triangles in the hexagon.
So the sum would be just
4 times 180.
So the number of triangle times 180 gets you
720.
All right. What about in a decagon?
Decagon, there were 8 triangles. So 8 times 180, which gives us 1,440.
Now,
there were some patterns.
Did you see a pattern?
Hopefully we all found some patterns.
Did you see a pattern?
Yeah, I noticed that, first of all, we're always taking the number of triangles times 180, obviously,
Okay, so
to get
this
that total
times 180 will get you the sum.
Right. But then if you also look at each of those number of sides compared to the number of triangles, it was always 2 less.
So like if I have 3 sides, if I subtract 2 from that, I'm getting the number of triangles.
Exactly. So like 4 minus 2 gave us the 2. 5 minus 2 gave us the 3. So for an n-gon, I'm guessing that it should be an n minus 2.
For the number of triangles. If
the number
there's
of triangles.
n number of sides, n minus 2 gives you the number of triangles. Now, why would we need to know that?
Because what we're noticing is to get the sum of the interior angles, we take the number of triangles times 180.
So number of triangles, now I'm going to put it in parentheses because I want that quantity times 180. That will give you the sum of the interior angles. Now, why would this be helpful? Well, you've been keep bringing up, well, if there's n amount of sides, like 17, do we want to create a table for that? No. We're just going to do 17 minus 2, which gets you 15, and times that by 180, and you can get your sum of the interior angles.
Exactly.
So much easier to do. Now, these are some theorems, believe it or not.
Oh my goodness, more theorems.
I know.
We haven't seen any for a little while.
If I can go with that. You want to go ahead and talk about it?
Sure. So the first theorem in chapter 11, it's the polygon interior angles theorem. And what we want to stress is it's for any polygon, talking about the interior angles. Because we're going to talk about something else in just a little bit that could detract us. So I want to make sure we remember that. So it says the sum, meaning that I'm going to be adding all of the measures of the interior angles of a convex n-gon.
Now, not concave.
Not concave. And I'll tell you that really the only relationships that you're going to notice that are consistent happen with convex figures. So that's what we're going to focus on mostly. All right, so the sum of the measures. So when I add up all the interior angles of the interior angles of a convex polygon of any number of sides, we just found that we were going to take 180 times the quantity of n minus 2.
And if you write it n minus 2 times 180, it's the same thing as like on the last
thing.
slide. So that gives you the sum of the interior angles.
Yes, and that's the important part, the sum of.
Okay.
Now, the corollary, so getting more specific theorem kind of branches off of this, it says that the measure of each, so I'm talking about each one, interior angle of a regular, now that's the key word here, it has to be a regular. What does regular mean again?
Well, it means all the sides are congruent and all the angles are congruent, so sides and angles.
Right.
And that's why we can talk about one of those because they're all going to have the same measure.
Exactly. So if I know that this is going to give me this 180 times the quantity of n minus 2 gives me the sum of all of them.
So that means all of those angles add up to that amount.
So how could I figure out what each one?
Well, if I know they all add up to a certain amount, that 180 times that quantity n minus 2, that gives you the whole sum. I'm going to take that whole sum and divide it by just one angle measure because they're all the same. Okay, or the number of sides, I should say, not number of one angle measure. Sorry, how many sides or angles we have. N means the number of sides, which means the number of angles.
Right. So, like, if I had, let's just say, 4 sides. Okay, I know that if I put a 4 in here, I could figure out the sum of all the interior.
So that
angles.
would be 180 times 2, which is 360.
Okay, and when I divide by the 4 sides,
because there's the 4 congruent angles
there's
too.
4 congruent angles too. That's going to give me what each one of those angles
that would be 90 degrees, which makes sense because if it's a regular polygon and it's 4-sided, we know that would be a square, which would make 4 right angles.
Exactly.
Okay, so again, remember that when you're talking about interior angles, the sum, how you found that. Okay, if you don't remember that formula, it is helpful, but just think about the process. That's kind of why I think we do the table. It allows you to kind of see where it comes from.
Right.
Now, the other type of angle that's involved in a polygon is an exterior angle. All right. Now, an exterior angle, by definition, I'm going to go ahead and give it to you, and I want you to look at this polygon and determine what we mean by exterior angle.
And we've seen these before.
This is not new. This is just a recap of something we learned actually first semester. Now, we purposely didn't have the angles that are inside the polygon labeled because we know those are interior. But notice an angle that is exterior is actually adjacent to an interior angle. Okay? So if you look at your picture, obviously these are all the interior angles. Think about that word adjacent to an interior angle. So if I look at, let's say this vertex here. This is the interior angle. What would be considered adjacent?
Well, like angle 1 would be adjacent because they're right next to each other. They share that common side and have no interior points in common.
Okay. Anything else at that vertex?
Angle 3 would also be adjacent.
So both of those would be considered exterior. Now, why not angle 2? Because angle 2 is what in relationship to that interior angle?
A vertical angle.
So basically 2, 5, I'm just going to get rid of all of the ones that are vertical to the interior angle are not considered exterior. Even though I know you're looking at it, you're like, well, it's outside the picture, but that's not the definition. Exterior, don't just think outside. Right now, Ms. Hochgraving pointed out that there's actually 2 different ones at each vertex, but what do they have in common, that angle 1 and angle 3?
Well, they're vertical angles with each other also, so they should be congruent.
They should be congruent. So when you're talking about exterior angle, you're really only needing to worry about 1 at each vertex. Okay, we're going to stress that again. But because they're the same, okay? So with exterior angle, you're only going to talk about 1 at each vertex. Now, what else are we noticing about the exterior and the interior angle?
Well, I noticed that they form a linear pair. Because together they're forming that straight line. Their sum should be 180. Linear pair, man, that's a word we've been using since chapter 1 also.
So the exterior and interior angles at the vertex, each vertex, are a linear pair.
Yes.
So that's something helpful because if I gave you the interior angle, you could find the exterior angle or vice versa. You're going to hear us kind of explore that here in a little bit of like why that would be useful. So this is a good reminder there, okay? Now, why are we doing this? Well, think about interior angles. We talked about interior angles, the sum of them. So exterior angles are kind of special, okay? This next slide is actually from your book, all right? This kind of shows,
it's a great visual.
It is a great visual because I think exterior angles, it's one of those that we could just tell you, but we like for you to see it happen. So the cool thing about exterior angles, in this one I took a pentagon, kind of like the last slide, and I took 1 exterior angle at each vertex. And sum means you put them together, right? You add them all up. So that's what I'm going to do. I'm going to put them all together.
So if we cut them all out, put them all together.
And notice when I do that, they actually form 360 degrees. Okay?
That's pretty cool.
So that's with a pentagon. If I do this with a triangle and I put them together, guess what? They're going to add up to 360 degrees as well.
Wow, that's pretty amazing. So any
polygon, doesn't mean if it's regular, it has to be convex, of course. Their sum is always 360 degrees. So imagine this, a theorem.
All right. So now we're going to be talking about the polygon exterior angles theorem. And that's why we stressed interior so much before. So interior, we've already talked about. This is now exterior angles. Again, 1 at each vertex. It says the sum, so when we add them all together, of the measures of the exterior angles of a convex, cannot be concave. Concave does not have all the cool relationships. Polygon. Again, talking about just 1 angle at each vertex. That's important also. I can't be talking about both exterior angles. Pick one. They're the same. Will always be 360.
So if you add up all the exterior angles, again, of any type of convex polygon, it will always be 360. So it's kind of convenient because you don't ever actually have to find anything. Like with the interior angles, you have to know how many sides it is, and then subtract that from 2 times 180. This one is just, it's 360. Okay.
Now, corollary, so getting more specific, talks about, again, a regular polygon. Now, I want you to think for a minute. If you know that the polygon is regular, we said that meant that all of the angles, all the interior angles, and all of the sides were congruent.
If the interior angles are all congruent, that means all the exterior angles are going to be congruent.
Right. And if we know the sum is 360, how do I figure out what each
interior or exterior angle is? Okay, well, if I know how many exterior angles I have, which is the same as the number of sides, I just divide 360 by the number of sides, which gives you just 1 exterior angle.
Exactly. Now, again, this one's kind of nice and short, short, sweet, and to the point, because we know that the sum is always going to be 360 when we're talking about exterior angles. So just divide by the number of sides.
So what I'm seeing is a pattern here. With the 2 theorems we learned, one was interior, one was exterior. So the actual theorem is just the sum. And then the next one gives you just one And this is an interior angle. Maybe make that so we can remember that.
Yes.
So, and to find just the one interior angle, it's dealing with a regular polygon. You take the sum divided by the number of sides.
Right.
And that's for both scenarios that we talked about.
Exactly. Oops, sorry. So here's sum divided by the number of sides. Okay.
All right, so let's try some examples here. And one thing I noticed right away, this one has no picture. So you can always draw a picture. You could kind of, if you don't need it, some of you are not necessarily have to have a visual. It's kind of up to you. All right, so let's kind of underline some key things. It says a heptagon.
Okay,
now,
so 7 sides.
7 sides. I like just kind of making that note because we're going to need to know that for any of these scenarios. How many sides does this have? It has 4 interior angles that measure 160 degrees. So each of those 4 interior angles is 160 degrees. So 4 of the interior angles is 160 degrees. Okay, so that each. Maybe write that instead of saying the sum. They're not saying the sum. And then they also give you 2 interior angles that are right angles, which means they're 90 degrees each. Okay. Now, notice you have how many total angles so far?
Right now we have 6, but we know it's a 7-sided figure, so we're just missing 1.
And it does say what's the measure of the other interior angle. So you could actually get by with not knowing 7 sides, technically, on this problem, okay?
Right.
So if we were trying to find that particular missing angle, we could draw a picture, all right?
Okay.
I'm going to try my best. So 1, 2, 3, 4, 5, 6, 7. Did I count it?
You got
1, 2, 3, 4, 5, 6, 7. Now this is not drawn to scale, so don't get too picky here. Now,
hey, but 2 of them kind of look almost 90-ish, so I'm going to go with you on that one. Look at that.
So this looks 90, and maybe this one looks 90.
I think that looks good.
All right, so the rest, the ones that we know, we don't know all of them, 160.
There's 4 of those.
Let's say these are all the 160. So the question mark is, what's that guy right there? Okay.
So really, if I knew what the sum of all the angles should be, I could just subtract what I already have from that quantity.
So if I can find the sum of those interior angles, then like you said, you're going to subtract what you do have from that. Now, how do I find the sum of the interior angles?
Well, we know that it's the 180 times the quantity n minus 2.
And the n represents
7
minus 2.
Because that's 7 sides.
So 180 times 5 gets you?
It'd be 900.
So that's the sum. So that means all of these angles added up get you 900. Now, that's not my answer.
No.
What do I do with that?
Well, now I need to subtract what we already know.
Okay.
So I could take the 900 minus, and I could do 160 minus 160 minus 160 minus 160 minus 90 minus 90. Or if we wanted to kind of condense some of that to, yeah, that's exactly what I would be doing too.
I know there's 4 of them that are 160, so I'm going to subtract that particular sum from 900 and then 290 degrees from that. And then when I end up with that, that means that remaining angle is 80 degrees. Now, checking this, you could just put this back in. Do these add up to 900 like they're supposed to?
And they do.
So, guys, one thing you're going to notice is that knowing the sum of the interior angles is kind of key here. If you said something about exterior, we know already the sum of exterior is 360.
Right.
But with interior, you need to make sure you actually find the sum. This is the kind of work that we would expect to see, okay? You don't have to draw the picture, of course. All right,
the next one says the measure of each interior angle. Ooh, each interior angle. I'm going to underline that, make sure we don't forget. Of a regular, it's a good thing it's regular, or else we couldn't necessarily do this. Regular polygon is 165.
So that means all of the interior angles in this polygon each measure 165.
Right.
Okay.
The question here is how many sides does the polygon have? So here, what is the piece, what is in our formulas, what is the variable
number
we've
of
been using
sides?
for number of sides?
We use n.
So that's the piece we don't know.
Okay. And I'm noticing it's talking about a regular polygon. So a regular polygon, if you know the sum of the interior angles and you divide it by the number of sides, that gives you 1.
What was that formula that we used?
So that was the 180 times the quantity n minus 2. And I'm dividing by n because that's how many each of those interior, or how many sides I have. That gives you just 1 interior angle.
Okay.
And I don't know n, but I do know that 1 interior angle. So I could set that equal to 165.
Right. So it's really just taking the formula that we know and making an equation out of it to say, okay, we know the number of the angle measure, each angle measure, to solve to find the number of sides.
Okay, so it's kind of working backwards. If I give you the number of sides, you could find that interior angle, but I know the interior angle, so I'm going to work my way around it.
Right. Now, you could put this over 1 and cross multiply.
I like that idea.
You could multiply both sides by n, but I think that probably most people would think to cross multiply here. And what would that give us?
So I'm going to do the 180 times n, so 180n minus 360. I'm just went ahead and distribute it. And times 1 is that.
Right.
Equals 165n. I'm going to subtract 180n on both sides. And then I'm getting left with negative 360 equals a negative 15n. And then if I divide by negative 15, I'm going to get n equals 24. And that's 24 sides.
Yeah, n was representing the number of sides, so 24 sides. Love it.
And that is reasonable. Obviously, we're not going to draw that picture.
I wouldn't
But
want to.
having 24 sides is a doable polygon, okay? If you get an answer that's a decimal, a fraction, or a negative number, think about that. Is that realistic?
Yeah, if you think about it, could you have 4.5 sides?
No.
You either have a side or you don't have a side.
Exactly.
So those should be integers.
All right, so here's another one. It says a sign has a hexagon shape. So we already know hexagon. What's that mean?
6 sides.
Okay. It says 4 of the interior angles measure 140 degrees and the remaining angles are congruent. All right, so they're saying 4 of the interior, keep in mind these are interior, all right, measure 140 degrees each, and the remaining angles are congruent. What is the measure of the congruent angles?
Okay.
Now, we could draw a picture, but I'm going to approach this without a picture. So we know 4 of the interior angles are 140 degrees each. All right? And
In fact,
know
right now we could say that's a sum of 560.
2 congruent angles left. Okay, this right here is a
That
sum.
was the sum of 560.
And how did you get that?
I just took 4 times 140.
Okay, so it took 4 times 140. I just want to make sure we're good there. All right, now, that's not the sum of all the angles. We need to find the angles that are the congruent angles that are left. So if I know what some of them add up to, what else
I
do
really
I
need to know the sum of all of the angles.
So I need to know the sum of all 6 angles. So how do I find the sum of a hexagon in its interior angles?
So I'm going to take 180 times our 6, number of sides, minus 2. So 180 times 4, which would give us 720.
Okay, so that's how many all together. The sum of all of the angles here add up to 720 degrees. Okay, now what am I going to do?
So let's subtract the 560.
From that?
Yes, from that, because that's the sum of the pieces that we do know, and that's going to give us 160 degrees.
Now, what
left.
does that that's representing?
That's representing what's left with the 2 congruent angles.
So these are the 2 interior angles.
So then obviously if I divided that by 2,
Because they're both the same,
right?
you're
'cause
going to be
they're
left
congruent,
with,
so then they're each going to be 80.
perfect. So this one you didn't have a visual, you could do it with or without.
All right, now this one, what are we dealing with in this picture? Are these interior angles?
These are exterior angles.
Exterior angles. And what do you know about exterior angles?
Well, bottom line, we've been talking about some of the angles all the time. So if we're talking about exterior, the sum of exterior angles is actually 360 degrees.
Okay, so here's the thing. If you look at this, we have an exterior angle at each vertex. That's what we want, one at each vertex. We know that the sum of all of these together should be 360 degrees.
Yeah.
So I can take my 2y plus y plus 2y plus y, and that should get me to my 360.
Every single time.
And that
That's
sum is going
6y.
to be?
And so y equals 60.
All right.
And you could check it, put it back in for y and see if do they actually all add up to 360.
Definitely. All they asked us for here was the value of y, so we are done. But yeah, I love that you said you can always check these two to make sure. All right.
All right, this one says the measure of each exterior angle of a regular polygon is 40 degrees. Okay, so the measure of each exterior angle, and notice we're talking about a regular polygon. And usually, guys, if they're talking about each of the angles, that probably means it's regular. If I didn't give you regular, this would be hard to figure out. Each of those angles are 40 degrees, okay? It says how many sides does this polygon have? So this is kind of like the one we did with interior. We just need to know what the n is,
Okay.
So let's talk about what we know. Well, we know it's exterior angles. Talk to me about what we know about exterior angles.
Well, we know that their sum is going to be 360.
So the sum of the exterior angles is 360. Now, if I want just one of those angles, which is what they're giving you, how do I go about doing it?
We divided by the number of sides. So divide by n because we still don't know that yet.
Okay, so we're dividing by, again, the number of sides to get that one interior angle. So this will give you that one exterior angle. And do we know the number of sides?
No, but we do know the one exterior angle.
So in other words, we're doing 360 divided by n to get you
40.
And kind of like we did on the other one, set up as a proportion, put it over 1, cross multiply. So how many sides are we going to have?
So if we take our 360 divided by 40, we're going to get 9 sides. And again, you should have an exact number of sides. It should not be a decimal.
Since they said how many sides does this polygon have?
This one's kind of nice because it's a little bit shorter than the other one.
It does take. Now notice, and I'm going to go backtrack real quick. Which one was that? This one right here? No. This one right here. When we found the number of sides, if given the interior angles, notice how much more work. It still gets you how many sides.
So it's just the formula equal to the number of sides. What if on this one, could I have instead... if I know what the interior angles each would measure, I really kind of also know what the exterior angles would each measure.
And
right?
guys, we want you to go back real quick. We're kind of trying to compare these two scenarios. They're both dealing with finding the number of sides. If I give you one interior angle, what do we know about interior and exterior angles?
That they're a linear pair.
So if I do 180 minus 165, that gives you...
It gives us 15.
15 degrees. That's for one exterior angle.
So could I have, instead of doing the way that I did to approach this with an interior angle, could I have said that the 360 divided by n,
the number of sides,
should equal 15?
Yeah, because this gives you the exterior angle. If you know the interior angle, then you know the exterior angle because they're a linear pair. And guess what? We cross multiply.
And you're still going to end up with n is 24.
So same outcome. And I know we kind of skip back and forth here, but this gives you an option, guys. If I was you, right, doing it this way is less work, of course. Now, this approach works just fine as well. So it's just kind of up to you, okay? I think we have one more example.
One more. Now, this one says, if you were designing a sign, would it be possible? So the question is really, is it possible?
Yeah.
To make a sign that is a regular polygon with each interior angle measuring either the 160 or the 115.
So we have two kind of parts to this.
Two parts. So
we'll do
two separate.
We'll do A with you guys, and then you guys
think about
B on your own.
Okay. Now, the question is it even possible? Now, what does that mean? Is it possible?
Then it might not be.
Okay, it might not be either.
We're not really. It's not saying like the last one didn't say. It said specifically how many sides. So this one, the only way we can figure it out is to figure out how many sides would it be for that angle, and then question that. Okay,
so let's go with that approach. So we know we're talking about interior angles, and I'm going to go ahead and on this one, go with the interior angle approach.
Okay.
So we're not going to worry about the exterior angles on this first one. You guys can use the method of your choice on the second one.
Okay.
What do we know about the sum of all?
It's always 180 times the quantity n minus 2 over n, and that gives you one interior angle, and that's 160.
And that's what they tell us, is that we want each one to be 160 degrees. And if I go ahead and put that over 1 and cross multiply, I'm going to get
180n minus 360 equals 160n.
So if I subtract my 180,
so I get negative 360 equals a negative 20n, and n is going to be 18. So 18 sides, that would work. We could have a polygon. So the question though is, would it be possible? So is that my answer?
That's not my answer.
No, so I would say yes.
Yes.
Now if they said explain, I believe that sometimes we'll ask you to do that. We've done that before. Explain. You could say because 18 sides is a possible.
It would be
answer. So explaining
and 18
basically.
gon is a possible figure, something of that nature. Okay, now I want you guys to try this one on your own and then check with us.
Okay, here's what I would do. I'm going to try a different approach. I'm going to find the exterior angle.
Okay.
If the 115 is the interior angle, if I do 180 minus the 115, I'm going to get a 65-degree angle. That's for exterior. Now,
Love it.
I know in exterior angles, they all add up to 360 no matter what. And if I divide that by the number of sides in, that gives you that 65-degree angle.
Okay.
So
let's go ahead and let's cross multiply.
So I'm going to take, so I get 65 in equals 360. And then if I divide each side by 65, here's what my calculator says. It says 5.5384, blah, 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 blah.
Is that a whole? Can you have 5.5384 blah 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 number?
Of course not. Of course not. So that means this is not possible. And if I explain, I said I can't have that a decimal amount of sides or
a
whatever,
fraction
of a side. It's in
you
other
either
words,
have a side or you don't.
You have to have whole amount.
They can be longer or shorter, but you either have the side or you don't.